Ciao, Luca. Hey, thank you so much for inviting me here. Here is one tip. If you talk to a New Zealander, do not use the word kiwi. In New Zealand, the word kiwi does not refer to the fruit, but the bird. What do we call it? But Americans do it the opposite. We call it kiwi fruit and kiwi. Americans say kiwi bird and kiwi. Anyway, welcome to this presentation where we're going to be talking about how a programming language, this kind of cultural artifact, can become a tool for addressing some of the world's largest challenges. It's not to say that a programming language has every answer, but it is a small part of a very larger story faced, and we're in a very strange position this week and this month and this year. And I'm hopeful for the future, and I think that Rust can be a positive part of creating that future. But I was almost, the organizers don't know this, but I was very close to canceling. Very, very close. And that's because last weekend, my 2-year-old was in hospital. At this stage, so she had pneumonia, so her lungs were not able to give her body enough oxygen to survive. And so she's been given high volume oxygen supplementation. And behind her is a device. When you are spending a few hours in a hospital with your baby, you start to look at everything in the hospital and wonder what might break. And so I was very curious. This device is perfectly safe, I should say. What it's doing is it's heating up the oxygen to about 22 degrees and adding, it is hydrating the air so that her lungs don't dehydrate and her throat, to avoid the damage that is caused by pumping oxygen into her lungs. And I looked quite closely at this machine over time. So it's very happy there at 22.1 degrees. And I noticed that there was this hamburger menu. And I thought, there's software in here. And so I probably shouldn't have, but I decided to touch the menu. I decided, look, this must be able to defend itself against hostile attacks. And so I went and had a look. I clicked through the menus a few times, and then I came to this screen. So Fisher and Paykel Healthcare, by the way, is actually, I'm fairly certain, New Zealand's largest listed company. So they're very good at software. They supply a lot of breathing and oxygen machines all around the world. And I looked and I said, that's interesting. It took them 22,107 versions to get it right. And I just kept thinking, did they run all of the tests every time? Was their continuous integration flawless? Was there some time when they sort of forgot the dependency and they weren't able to package the build? Like, did they get that everything correct to keep people alive in their most fragile state 22,000 times in a row? While also having to operate this operating system, I don't know what operating system it is, but it has been updated 963 times. Now, we are in quite a dark place currently. Very close to here, there are 2 major wars occurring. And more governments are going to be using software to attack each other. The energy consumption from everyone's electronic devices will increase into the future. This will continue to go up and up and up. And we need to be able to make energy-efficient programming language like Rust easy to use. We also need to be able to make sure that we can update our software, let's say 22,000 times, and make sure that the next version is going to work. If you've ever had flaky tests, but I just keep wondering what these people were like, what if it breaks? All it needs to do is check the temperature, increase the volume, and decrease the volume. The temperature and the reason why this was particularly bad, I'll go back to this to the thing. The reason why this was particularly crazy to me was a couple of weeks before this. My fish tank killed all of its fish. The heater decided to just continue to heat the water, and they all died overnight. And software is just so awful. All of the time. It is like clearly there's a microcontroller that was ticking the temperature and then deciding to just continue to go on. Like, is there a bug in this version? I don't know. And software could be, this is the problem with web slides. Software could actually be reliable. We could expect that software works. At the moment, we don't. We sort of we have this hesitation around applying updates. We expect that things to be brittle and to break. That's not essential. Other industries, which we will look at, were very fragile and over many decades have become more robust. We could do the same thing. Software could be secure. That does not mean that it will be perfect. But we could do better than we are currently doing. And software could be efficient. I spent a lot of time working in, I'd say, the cloud industry. I at one time worked at AWS, and so spent a lot of time talking about people that really love the cloud. And what I noticed about people using virtual operating systems and virtual computers is that they are very keen to make sure that their piece of software does not crash. And so if they know it's like, we probably need 4 gigabytes of RAM, which is actually quite a lot of RAM. But then they will provision an 8 gigabyte instance, just to be safe. And everyone is over provisioning. And that doesn't need to be the case. Has anyone run like a web API written in Rust and just been astonished that this thing only needs like 50 megabytes of RAM? Versus say like a Python or a Java or anything else where we're talking about gigabytes of memory. Could we create a better future? Well, maybe. But here's a problem. I would like everybody in this room to spend some time to think about the bug, and it's not a trick question, the bug in this code. Like it literally is applying multiplication. And maybe this makes it more obvious. We're going to crash at runtime. There are sort of one of the problems of Rust, even in Rust, we think we're Rust programmers, so we're so very good. But there are like panics lurking everywhere. If you multiply 2 arbitrary numbers, it's it's possible that over 97% of the combinations of those integers will crash your program. So before we think about the ways that Rust might be able to fix, I just wanted to spend a little bit of time about looking at other industries that had horrific safety issues and decided to fix things. And all of the Italians in this this room will have recognized this photo. But this was novel to me. And I don't want to pick on Fiat here, but I just thought that this building was incredible. So it is one of the first, it's a marvel of modern engineering, one of the first reinforced concrete structures. It looks small because it's up on a slide, but these walls are about 500 meters long. This thing is huge. It's 5 stories high, and it's all a giant spiral. So the raw materials were shipped in at the front, and then as cars were built, they would kind of move around and then go up and up and up and up and up, and then they would reach the top. And doesn't the roof look very strange? That's because it was a test track. And so every vehicle that was built, I don't actually know if the whole, they probably changed this by the time they reached the 70s and closed the plant down. But yeah, you would test your vehicles that you built on site in the ceiling, and then they would be able to drive back down to the ground and out the door. So this is kind of amazing. It's something we would never do today, but at this period, the automobile industry was awful. Horses were probably still better at this point. They were reliable, their tires worked, the brakes were better, the brakes were bad, the lubricants were bad as well. There was nothing good, really, about the motor car. It was noisy, and except for the fact that, actually, I don't want to go into a big digression about the history of the automobile industry, except that things got things got much better very quickly. Because, and now we expect that our car is safe. We do not worry that there is, I mean, some people do, but it's unlikely that we check before a long journey, like, is there a spare tire in our car? At this time, if you were to travel for more than 200 kilometers or so, you would have made sure that there was spare tires because the rubber was not strong enough, not robust enough, and it might explode. Now, this is a funny picture, and I just want to say this is just something else that I found. It's really hard to see, so I'll just zoom in slightly. There's an electrical box that multiple people are working on, and we need to guarantee as a team that we do not electrocute each other. So, everyone has their own padlock. And you can only unlock, like turn on the switch if everyone has unlocked their padlock. It's a nice way to look at sort of an analog safety mechanism. And it sort of, this does not, like, even though it looks novel, it looks obvious now. Someone had to think about this, and it's very creative. It's very simple, it's very hard to get wrong. And what I like about these sorts of systems is that they are very easy to understand. The individual just needs to plug in their padlock, unlock they have responsibility for their thing, but the whole system is designed for success. We don't give someone sort of a special lock that can break everything, or everything is easy to use. Our software tools should be easy to use, and also they should be they should default to safety and strength and reliability. The principles of engineering that this part of the world and like the West, one of the things that Western Europe and the Americas do very well is engineering. And we can make software equally as robust. We should expect this from our systems. But what is Rust's role in this? Oh, that's again, the downside of these web things is that apparently the layouting system is just awkward. Rust is a better default option than C++, for new software in particular. For that, I think that Rust's position should, instead of saying, why should we choose Rust? the question should become, why should we choose C++, or why should we use an unsafe language? Shift the discussion and bias towards safety. If you really need the tools that might break on you, then they are still available. But Rust should become a default position. One of, I think, Rust's strengths is that it is accessible to everybody. And what I mean by that, I really like the empowering everyone message that the Rust language has right at the top. Because the Rust community was able to bring in elements of positivity from Python or from JavaScript. One of the reasons that Rust is so attractive to C programmers has nothing to do with the language, but its tooling, its build system. Cargo is not part of Rust. And yet, when you talk to people about why they use Rust, they will say, well, cargo build, my dependencies problems are solved. And that happened because Rust included individuals from other disciplines. And I think that we can continue to make sure that Rust is a welcoming place now that it is mature. Rust is inside the Linux kernel. It is inside the Windows kernel. It is mature. It is no longer a new language. And so the same messages around accessibility and being welcoming need to change. Because now if you are a beginner and you want to contribute to the Rust project, you need to decide which of 10,000 issues, or let's say hundreds of RFCs, or thousands of Zulip messages. We should be very mindful that being accessible means adjusting the way that our community interacts with newcomers, because Rust looks different than when we were here, when we started. Everyone in this room, I expect, has used the Rust compiler. Most of the world has not used the Rust compiler. And therefore, Rust looked different for you. And your experience of being a newcomer is different. Anyway, I should possibly move on to say that one of the other very positive steps that Rust can, one of the very positive roles that Rust can play is that the Rust community could be a role model and can model positive behaviors for other communities. We can think about the way that we interact with each other. We can think about the way that our tooling interacts with developers, sort of the developer experience. We can say that we want to default to safety and security first. This has started to affect other language communities. C++ is very concerned about memory safety because it's a very large problem. And that's because of Rust. That's very positive. One of the things that I like about Rust is that this bug will never occur. So this is some Python code. Also, the world's worst implementation of the Fibonacci sequence. For anyone who is not, let's say, code literate, this is an infinite loop created by accident. Rust's borrow checker will make this type of bug impossible. This comes at a cost. The cost is that it's very difficult to learn because suddenly you use a loop with a vector of things, and then you do it, and then suddenly you can't write the programs that you expected to before. But you cannot really, I don't think it's possible to turn the borrow checker off. I'm probably going to find, someone's going to say, well, actually. But Rust defaults to the right behavior in this case. Python will have no trouble running forever in calculating Fibonacci. But Rust has its own problems. We've just seen one. We've like with multiplication. So we're going to play. Speaking of being a father, like spot the difference between these two functions. Structurally, they are identical. Can anyone describe why the second example refuses to compile?
String is not copy.
String is not copy. Who thinks this is an obvious reason? It's pretty obvious, right? It's actually, How many of you have taught Rust to beginners? And one of the questions that they will have, even if they don't ask you, but you can see it in their faces, it slowly distorts. They say, when you start with a programming language, you start with numbers. And then all of a sudden, you move on to text, and your code starts to break. And then we need to sort of talk about the copy. And actually, but I thought copy was related to methods, because my mental model is that copy is a trait, and a trait is sort of like an abstract base class. But I look at the definition, what is copy? Because it has no methods. So now you're spending time explaining mark traits to someone who's like 20 minutes into a lesson on the introduction to Rust. And to me, I don't think that I don't know if this is sort of possible to solve. But it is a warning to us that we cannot be so arrogant to think that Rust is some perfect language. It is just a programming language. And it is difficult to learn. At least there are parts that are surprising. Next example. This one is much more subtle. Now, imagine that you have implemented this defer. So you've been a Go programmer for the last 5 years. GoLab is like a couple of days away. So you've implemented defer in Rust, and you know the way to do this is with the drop trait. And so on drop, you will then execute this closure and do any cleanup that you require. In fact, there is some working code that we're going to show, but what is the difference in behavior between these two? Does anyone?
Is it immediately dropped?
It is immediately dropped. One of the consequences of the underscore is the the compiler says, oh, you don't need the variable, I'll drop it now. Which defeats the purpose of this defer thing in the process. In fact, if you use cleanup as is, you will get a warning for it's an unused variable. You should replace it with an underscore. That is the help. And so just remember that this is very, let's take a look. Okay. So here's my implementation of my defer function. Takes a callable, which it can call once, and returns a deferred. It contains a task that has sum inside. On drop, if the reason why I use an option is that there's the ability to abort a task. And options have a take method. Take will pull it out of the value, return none, and essentially ignore the sum. So this is the way that we can abort our task. Now, if it is there, then we call task, which is kind of, I think, it's like an extremely, it's very sophisticated and a very nice, elegant way to solve this problem. But yeah, here's our unused variable warning. But notice that work 1 with the warning creates the behavior that we are interested in, but work 2 does not. Now, is this sort of some sort of scary magic? I don't want you to suddenly worry that all of your programs have different behavior than you expect. But I do think it is important for us to remember that Rust has some strange corners and and it's a big language. This is a very sort of bizarre rule and it is we should use an underscore because we're trying to be good. We don't want. In fact, if you were to, I actually was thinking about this on the train on the way here. If you ignore the variable at all, I think that the behavior will be correct again. No.
If I remember correctly, if you do underscore a, the variable is correct.
Okay, so let's try this. The comment here in the front said, well, actually, if you, well, not in a nice way, if you give it a name, then it will work correctly. And so this is just very subtle, and just it demonstrates that Rust's behavior is not obvious all of the time. I am going to try to persuade you to do something which your intuition has told you to ignore for a long time, and that is to use static analysis tooling to be able to identify and prevent bugs occurring in your programs. And therefore, the obvious question that I need to answer is, well, if they're so good, Tim, then why does nobody use them? And obviously, there's an asterisk there because an increasing number of people do use them. So most people are busy. That's why we're at work. And in fact, everything is on fire. Like, if you look into any large enough code base, there are tests that fail for strange reason. CI takes far too long anyway. People want builds. People want features. Do you really care that the variable underscore is in the right place? Code review takes long enough already. Tim, God. I'm asking you to add more cognitive load to actually increase the friction to releasing software. At least that's the way that it feels. One other thing is that claims around productivity or improvement of software quality are almost impossible to believe because it's very it's like describing the difference, but it is software is ultimately a creative thing. It's similar to like a novel. Like if we write poetry, different poets write different poems. We accept that. And so saying that some poetry is better than others is, and therefore I'm trying to say that some tools will be difficult to, like I can't say that I've made a 10 times improvement to your code and I've eliminated 20 hours of fixing bugs. Because prevention is almost harder to measure than software. It's like, did you prevent the forest fire? Well, yes, like there's no forest fire today. And so, so intuitively, we need to be able to feel comfortable that sometimes we need to use our own judgment. As people who are highly analytical and very smart, it's very tempting to say, well, the numbers look like this. Our metrics will go down if we do something. But in practice, everything is much more difficult to quantify than we would like. The other thing is that because everyone's busy, learning some new tool actually decreases your productivity before it improves. Nobody likes to feel like they are ignorant or that they are stupid. And learning a new tool, especially one that might feel academic, uses very academic language for experts means that your feelings towards this tool decrease. Your productivity will go down as you invest time to learn a thing, and then it may never get to the heights that you were promised. Every programming language comes out and says that your productivity will be improved. I think I've seen that in every single programming language that's ever been released. That suddenly this new programming language is going to be easier and you're going to be faster. But I don't know if we have any way of validating that is even possible. Yes, I think we can build a better future. Let's look at our example again. Here is multiply. I want to add a sort of something that looks like a test. This function, verify that we can multiply. We take a mathematical representation. It's like we want to be able, A and B could be in any number. And now I want the tools to check mathematically, is this possible for every combination of values? And importantly for this particular tool, it does not actually evaluate it exhaustively with brute force. It goes and mathematically solves, it converts this into a form which a formal theorem solver can go and validate mathematically or sort of analytically rather than doing it manually. And this is how hard it is to use. Once you have written the thing. Like once you've written the test. There we go. Failure. You've just prevented a panic in your code. Is this good? That depends on you. It depends on your particular your tool, but I think that's really positive that we have the ability to, these tools exist now, and in fact, in the repository for this talk, we may as well go and look. Before though, I want to show you some other suggestions. You have the ability to make your life harder by increasing the robustness of your code quality, by increasing the number of allow by default lints. Do take a look at all of these, or at least some of them. If you're shipping production software, you may wish to actually move allow to at least warn. The compiler can check all of these probable bugs. And one of the reasons why they exist in allow is that sometimes they are, because there's debate, where should they live? But you can opt in to making your life harder and making your software safer by just adding an extra line to the top of your crate, saying, like, warn extra, so for example, if you are releasing a library, it is a good thing to have proper documentation for your public items. So if you add deny missing docs, your code won't compile if you have released some public item which is not documented. Again, this feels like it's making your life harder, but it's actually sort of making things, I think, a little bit better. Clippy is another tool, and I want to show you one of its groups that is probably not recognized. These are allowed by default, but it has performance lints. So there are a couple of dozen of checks that Clippy can perform with cargo Clippy, which are known performance problems. So you can improve the speed and quality of your code just by using these tools that exist today. I would like to introduce you to the Miri interpreter. And I don't often drop a 0-day in a public talk, In fact, this will, but I tried it last night and I found a bug, so we'll see if this can happen again. Example, actually, no, sorry, that's next. It's the fuzzing one. So I want to create a doubly linked list because I'm a Rust programmer and I came from, and I think, you know, because my background, I'm actually a Python developer, but let's pretend that I am an expert C developer. And so I think, you know, I can use pointers. So what I have here is a code base where my tests pass. I've got some use after frees in there. I've got a couple of double frees. But the actual behavior is perfect. And now what we want to run is cargo Miri test. So we want the Miri interpreter to go and, oh, sorry. For technical reasons, it requires the nightly compiler. Oh, the test failed. It found bugs that our testing was not able to. Now that's a really good thing. It can actually go and check inside your unsafe blocks that you are doing the right thing with your pointers. But sadly, not everything. You'll see that there is on the left here, we have another folder, uncaught. So it is not a perfect tool. It's still under development. In fact, none of these are perfect tools, but they improve the quality over time and are worth looking at. Next, I would like to show you fuzzing. Fuzzing is the idea which we could test our programs by injecting arbitrary data, shove it into the command, and see if it works. If you go into the website for the fuzzing, or for Rust fuzzing, which I had open, it has an example of going and finding a URL library and applying the fuzzer to that against a specific branch where they know that there was a bug. And they say, don't worry about doing it on main, because you won't find one there. All right, they don't quite say that, but it seemed like that. So example fuzzing, Rust URL. So this is public. This is from the, and I go into URL. So it's a subcrate. It's a project made up of multiple crates. And then I run cargo. I spell correctly. Fuzz, run, parse, and I would say a maximum time 100 seconds. Boom! We found a bug. We've just been able to find an input to this library that will crush, that will cause a panic in production. This URL will break, this so-called URL will break Rust URL. So you provide this input to the, and you've just created the vector for creating a denial of service attack for anyone using that library. I think it's hard to, so the way, and how does this work? So over in Fuzz, you require, sorry, this tool enables, requires you to define a function which accepts arbitrary data if it can create, and then it performs some sort of analysis. If the program crashes, that's bad. What we want to be able to do is parse it as a URL, and if the library thinks it is a valid URL, be able to get it back as a string and get it back. So if this fails, there's a problem in the library somehow. And that's what we just verified exists. Like there's some issue. But the tool that I demonstrated before with the multiplication does not require tens of millions of inputs to a program. Again, it is your code is checked by a software tool and analyzed at a mathematical level, is this theoretically correct? And will it break? It is harder to use because you need to define a bunch of assertions and things. But here is I thought, you know what I would do? I would implement a circular buffer. And because I need performance, I'm going to use the raw pointers. So here's my circular buffer. And I think, oh, look, I can just go and use unsafe. And you see this and you think, oh, gosh, I don't know how to verify unsafe. I don't know if you'll manage this correctly. What we can do is ask Carney, verified circular buffer. And I'll just give myself instructions. So there we go, cargo Carney. So that's all that we should need to do. Oops. Ugh. Oh, and somehow I've gone and broken my test, my example. But that, you were supposed to magically clap at the end of that because it was correct. We actually were using the unsafe in our raw pointers correctly, but apparently, now I know, I think I know how to fix it, actually. So these assertions, it has this assert function, which require you to provide a message, but I don't want to go and run that because I'm kind of running a little bit close to the end of the talk. When I started with Rust, and again, I actually learned Rust before the official book was published. So I suppose I'm quite old now. And I am one of the few people that have never read it because I wrote my own book and I didn't want to be accused of copyright infringement. And so I thought, I'll leave that over there. But I remember this. I remember people talking about fearless concurrency. When Rust was first released by Mozilla in about 2012, people were extremely excited because you could use multi-threading without fear. This kind of liberates you to experiment with new ways of programming, which were previously thought essentially as impossible. Concurrency, especially high-velocity, high-frequency work, was seen as something for experts, not something that ordinary programmers could use. What about something else? What about the idea that programming software itself could feel liberating? I love programming in Rust because I don't want to ever worry that I have some sort of name error or that I'm accidentally creating an infinite loop. I would like more of that. It's one of the nicest feelings there is, the idea that once my project compiles, it works. I'm not going to cause security vulnerabilities for tens of millions of users. I don't have any software that's used by tens of millions of people, but probably people in this room do. And if you use an open source library, it's extremely likely that your impact is much larger than you think. And I really don't want to be the reason why people died because of a memory safety violation, which crashed the device which is keeping someone alive. I don't want to program in this kind of scared way. I'd rather know and trust that the system will protect me in the same way that I only need a padlock but I know that I will never be electrocuted by my colleagues. I think we should have, that would be nice. So here are a couple of ideas. Beginners are actually not stupid. They just are adapting their mental model into a new paradigm. There are more beginners than there are programmers. We think that the Rust programming language is big now. Probably no one actually. Do we think that? Or that Python is big now? This is just the start. In order for software, so software is sort of the greatest leverage, political and practical leverage that individuals have. You have enormous power when you build software. And you need to bring people with you. Your tools should be coaches rather than simply saying no. The Rust compiler does a welcoming, really wonderful job of saying, if that's what you want, try these 3 help messages. It can feel annoying because sometimes you just like, go away, I know what I want. But that's because we look at those messages with the eyes of someone with expertise. As someone that is learning a new tool, having very helpful error messages and a very easy way in, your API is ideally simple, is perfect. And I want to talk a little bit about language that we use. I think of the term formal methods in particular. By design, that sounds exclusive. And it sounds like something that is very mathematical and very theoretical. But that creates a psychological barrier from anyone thinking that they are welcome and that these are tools that they should use. And when you're writing documentation, I have one tip for you. Avoid the phrase, "This is easy." When you're writing docs for beginners in particular, you have a tendency to describe things in terms like, oh, this is trivial. But for someone learning, it is not. She's fine. This was a message sent to me while I was on the plane. And with that, I hope that you can share with me a very hopeful, I love being idealistic. And I hope that we can have a more hopeful future together. My name is Tim Clicks, and I'm on the planet to build a better planet. Thank you.
Thank you, Tim. It's Q&A time. Yay! Raise your hand and I'll get you the mic. Questions? Yeah.
I saw Kani, but I wanted to try it. But how big can the function be using Kani? Have you tried it, or?
Yeah. So the question is like, how big can this be? Is it able to? I think it's probably best to start small and find where Kani stops. There are some other tools that I know, for example, there is actually quite a vibrant community of researchers creating static analysis tools in Rust. Kani is one of the better ones. It's very well funded through AWS, and they have a strong financial incentive on the correctness of their code. And so, but there are others, and maybe if you're creating a small, like a library, or you have a function with clear inputs and outputs, the hard thing will be to define the contract. So these Kani any parameters can be more specific if you know more. And once your code is more complicated, it is a tool that is harder to use. And so potentially, when you're starting, give yourself, don't try the hardest thing first, and find the find the barrier. One of the other problems that I've found is that it will try to run for a very long time because the solver has lots of possible paths to choose. And there's some skill involved in deciding or figuring out how to give the tools like a smarter path forward.
Thank you.
Questions?
Do the tools you've proposed work in no standard environments? And if not, what do you propose any ideas on how to verify such programs?
So the question is around no standard. So no standard says that you do not have things, you don't have the standard library available. This is typically when you're deploying to, say, a microcontroller or something without an operating system. So you might not have the ability to have virtual memory, for example. I don't have the knowledge to know, but it's very easy to check. So, but here is my suspicion that you could run the tests under like a 64-bit machine with an OS and have the same code compiled to your target, and you know that you've verified in one, and therefore the software hasn't changed. As long as there are no compiler bugs, then it should be work. But I don't actually have enough information to say.
So first off, thank you. And second, I'm curious about the overview of different tools that you gave. In particular, we talked about fuzzing, and then we talked about formal methods. And there's a nice sweet spot that exists in between the two with property-based tests. And I was curious about, that seemed like
that was
an
not a deliberate omission.
Okay,
I apologize.
I was curious about your take on those.
So it wasn't so property-based testing is very similar to that Carney method, where we kind of create special tests, and their job is to sort of explore the space a little bit. It's sort of halfway between fuzzing, where we have random input, and something that's more formal. There was no real deliberate reason to leave them off, except for the fact that, so it's one more as well, which is called mutation testing. So mutation testing is really fun. The idea here is your tests stay static, okay? But why don't we modify the program? If we've modified the program enough, surely the tests would pick up that the behavior has changed. And that is also available through a cargo package called Cargo Mutants. Property-based testing is available through car prop test, and I think there's also a quick check package as well. But they all operate in a very similar way to this style of essentially declaring things that look a little bit like normal tests with their own compiler annotations. You can have a, sure, okay. I don't know if that will make a recording, yeah.
Your motto is fine.
What are your questions?
Yeah.
Questions?
Okay. Grazie mille. Thank you so. Oh, well, actually, we're finished. We're done. We're good. Oh, that was nice. Oh, we got more hugging happening. That's nice. Thank you all so very much for your time today. I'm looking forward to saying hello and during the conference. Please say hi to each other and create the stronger community that we all sort of aspire to. Thank you.
Team McNamara.